Okay, guys, so we're back, and we're going to be finishing up the CPU shortly. So there's a few things we need to do to finish this up. First, I need to come over here, and in my last tutorial, I messed this up, so I need to fix this. So over here, we blocked this off for our bus, and we actually don't even need to. We could just remove that because of the way we did this. So it was either that, or you could break this sign, and we could put a redstone on it, and that would have made it continue going up. But this works now. And then now we have to do one other thing. You'll notice there's a line down here, this purple line, that isn't hooked up to anything. What we need to do is we need to create a falling edge monostable, which the output of that will go to that line, and the input of that falling edge monostable comes from the clock. So the clock also has to come over here and hit this. So if it has to hit, actually we're going to use this busing color. So if it has to come over here, I can wiggle my way through here. Okay. Whoops. Alright, so this is going to be the clock line. Which we need to also break off. So how we're going to do that, so we're going to come like this. And then this is going to have to come down into a monostable. Okay. So we need a special type of monostable, not a rising edge, monostable. We need a falling edge monostable. So basically when we give it a pulse, when we give power, we don't want the a pulse to happen until we remove power from it. And so what this is going to do is it's going to allow us to set up a clock for our CPU that says on the first half of an instruction, we're going to be reading our registers, we're going to be doing that kind of stuff, and on the second half of our instruction, we're going to be writing. And so that's how we're going to handle this, and then we can add delay to it as we need to. So first, I want to make sure we get redstone that reaches. So here it looks like a fine spot to do this. So I'm going to remove power from this. We're going to come down here. And what we need to do is normally on a monostable that's rising edge, we put more delay on the non-inverted side than on the inverted side. And so on this one, we're going to put more delay on the inverted side, like this. So we're going to put 4 ticks there. And then we can put 1 tick here, like this. And now we have a 2-tick pulse falling edge monostable. So I will demonstrate. No pulse when it's high, but we get a pulse when it's low. That might be easier to see if I use a torch. We got no pulse out when I put the torch on, but watch what happens when I remove the torch. Ready? We got a pulse. So now let's say I used a 15-tick clock, or let's say a 22-tick clock. Let's just make it pretty high. It would give us 11 seconds of delay, or 11 ticks of delay for reading stuff, and then right after that 11 ticks, it would send out this pulse when that falling edge happens, saying go ahead and write those values. But we can use a faster clock speed and then just put more delay on this line here. So that's probably what's going to end up happening. But let's connect this up. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, no. I'll recount this out. 7, 8, 9, 10, 11, 12, 13, 14, 15. Damn. Will that reach? Yeah, awesome. Cool. So now we have a way to hook up a clock line to this. So now what we want to do is here we're going to branch to line 0. So to branch to line 0, we're going to put an input here on a branch line, and we're going to give it a clock, like so. And that cleared it to line 0. Now what we're going to do is we're going to program this thing to put a value in a register. So the way we're going to do that, we're going to come over here and we're going to say, how do we get a value into the ALU, or into a register? Well, we're going to use the load immediate instruction, which is number 8. So we're going to have to put in the yellow spot, we're going to have to put the value 8. So least significant bit is here, so it goes 1, 2, 4, 8. Okay, cool. Now, blue is read register on the left side, red is read register on the right side, and green is the write. So we're going to be writing the value that we want into register number 1, and we're going to be saving the value number 1 into that register. So now to see if this works, what we're going to do is we're going to clock it, it's going to read this, and then on the falling edge it created the pulse, which came down here and then clocked this. So what should have happened is that this number 1 should be stored into a register number 1. So how we check that is we come down here into the decoder. Oops, if I can get down, and we see where is value number 1. Well, this is value number 1 right here, so that means this is register number 1. And we look to see if that value is stored. And it's hard to tell with these registers. The value is not stored, it looks like. And why is it not stored? Let's make sure we're still outputting number 1. Yes, number 1 is coming through. It's allowing it to come in. Nothing is happening. Wonder why. I will need to debug this. Okay, after some consulting, figured out what the mistake was, and we're going to go fix it. So this is on a mock CPU down here, so we're going to do it up here. So we got to come to the bottom of the ALU for SS reasons. Alright, so I'm still in spectate mode, and so we're going to come over here, and you'll see that we have this repeater. So I'm going to go into G mode 1. I'm going to remove this repeater, and we're going to place it right here, like so. And now we have our output. Okay, so now that number 1 is coming through into our register, we're going to, branch to line 0 again. And now we are going to try to do line 1. and see if the value was stored in the register. So this is off, and that looks like it's off. So I think that value was stored in the register. So let's see what happens. Let's just keep going. Okay, so we have the value 1 stored in a register. Let's do... so to do Fibonacci, we need 3 registers, so we're going to call them A, B, and C, and let's write down the algorithm. So I will use this here. Okay. And I need a sign, which I can steal from right here. Okay. So for simple Fibonacci with 3 operand system, A, B, and load, or A, B, and write. So what we're going to do is we're going to say A is equal to 1, B is equal to 0, and C is equal to 0. Okay, cool. So that's what we're going to start with. So what we did is we called register 1 A, and we set it equal to 1. We're going to call register 3, 2, and 3, like that, and we're going to set them equal to 0, and we're going to use the load immediate function here, like that. So now we've initialized our registers like good programmers. Now what we're going to do is we're going to say B is equal, or actually we're going to do, B is equal to, I guess I'll do it, is equal to A plus C. Come on. Then we're going to say, so now if we ran this, so A starts at 1, so the first thing we're going to do is we're going to do 1 plus 0 goes to 1. Okay, cool. So it should go 1, 1, now we need a 2, so now we have to do C is equal to B plus A, and then obviously all we have left is A is equal to B plus C. And then we'll just need to make sure that we can loop. Okay. So now we want to say we're going to save to 2 and we're going to load 1 and 3. So what we're going to do first is we're going to save to 2 and we're going to load 1 and we're going to load 3. Oops. And we need to do the add instruction, which is number 1, if I recall correctly. So up here, add instruction is number 1. Nice. Okay. So now we need to do C is equal to B plus A. So now we need to load B, which is going to be 2. We're going to have to be making sure we're doing an add. We have to load A, which is 1. And we have to write to C, which is 3. Okay, and then now we have one more to do. And we have to read from B and C, which is 2 and 3. So now we're going to read from 2. And now this one will be 3 instead of 1. And now we're going to write to 1. Here. Right, because we're writing to A. Okay, so now what we need to do is we need to loop back to where it says B is equal to A plus C. So that B is equal to A plus C is right here. So we need to loop to line 4. So what we need to do first is we need to do a compare instruction, which also we can't forget to put in our there. So now here we're going to do compare 0 with 0. Of course 0 is equal to 0, right? So what we're doing is we're basically doing a non-conditional branch. We're just saying go here anyway. It's basically ignoring the condition. So the compare instruction is instruction number 11. We're going to read 0, and we're going to read 0 here. We don't write anything, and that will update our flags. Next, we want to branch to line 5, or 4 was it? Branch to line 4. 1, 2, 3, and then yeah, here's line 4. This is where we do B is equal to A plus C. This is where we do C is equal to A plus B, and this is where we do A is equal to B plus A, or B plus C. So yeah, we want to loop to line 4 here. So to do that, we're going to put in here. We need to be searching for a branch of equals, and so branch of equals, if we look up here, is actually in the wrong spot here. And I was using orange. Alright, so those bits were actually here. And so branch of equals 0, 0, which I don't feel like writing it. So we're going to put 0, 0 here. And so basically this is saying branch of equal, and then we need to tell it to go to line 4, which would be here. Okay, so now what we're going to do is we're going to step through this and see what happens. Okay, so it's on line 1. So line 2. Line 3. Okay, so now we're on line 3. Now line 4 is going to start the loop. So now this should put the number 1 in register number 2, which is going to be impossible to actually verify if it's in there because of how compact everything is. But so right now the ALU should be outputting the value 1. And it's not. And we should be reading from somewhere that had... So if we come down here, it should be telling you which line to be reading from. And it's saying read from this line right here. Is that the issue? Read the value 1, that's reading the value 2. Oh. Yes, we never put signal strength extenders. Alright, so there's a few things we have to do before we can finish running this code. Okay. I'm just going to come in here, every other one, like this. I'm just going to flood them. Okay. These don't have to go down anywhere, but we're going to leave these just in case we decide to add on to the ALU or the CPU later. These over here, let's decide to read, and we will put. I need repeaters. Okay, those reach. The reds go anywhere else. Yep, they come through, and that reaches also. Okay, let's go to green. Green comes down here, and green reaches. Yellow reaches up and down. Oh, we need to make sure that we have repeaters here. This is just for synchronicity. And then now, if we allow our signal to come through here, it doesn't go very far, so repeater. Here we need, we're going to do it like this. We're going to try to get as much signal strength as we can on that. Like that, and then here we'll put the repeater here. Okay, and they all reach. So that is good. Okay. Now we can put this redstone back here. Okay, now it will obviously reach to those right there because that busing isn't very long, and it reaches up here. That's good. And I think that's every bus that we need to check lengths on. Okay, let's get rid of this stuff then here. Okay, so let's branch to line 0 again. Alright, now we're on line 0. Let's go to line 1. ALU should be outputting 1, and we should be able to see it right here. Yeah. So what I'm going to do for ease, just seeing what the output is lazily, then I'll put a lamp. Okay, so ALU is outputting 1 on line 1. It should then output 0, which is good. Then it should output 0, which is good. Now it should output the value 1. And it does, nice. Now it should load the value 2. Nice. Now it should load the value 3. Nice. Okay. Now it should say compare 0 with 0, and it should throw out the equal to flag. So, little lag because it just executed that. Let's come over here and see if it threw out the equal to flag. No, it did not, because we have 4 ticks of delay here, and it looks like we're going to need some more ticks of delay, so I will add 4 more ticks like this. I will then reclock it here, not the CPU, but the line that tells it to update the flag, and then now we have the equal to flag. Okay. Let me refresh my chunks here. Alright, so now that we have the equal to flag, let's clock to the next line here and see what input we get coming in. Huh, it seems to have gone to line 0 on its own somehow. Let's try this again. Huh. I'm not reading an instruction right now. Huh. Oh, maybe this is supposed to... Oh. Okay. Yep, we're gonna put a repeater here. Like that. And we're gonna come down here. We're gonna place our redstone that wasn't there. Okay, so now let's try this again. Let's go to the line 0. Alright, so we should be outputting 1. And we are. Okay. So let's go to line 2. That should be outputting 0. Line 3, that should be outputting 0. Line 4, that should be outputting the number 1. For some reason it displays at 8 like that. That's weird. Okay. So it's holding the number 1. Now it should be 2. Nice. This should be the number 3. Nice. This should be the number, or this should be, it's comparing. This should be comparing two values together. And I don't know why. Okay, it put out the right flag, but I'm not sure if it put out the right flag because that was the flag that it had previously. So we'll have to do some debugging. But it's not. It's the same thing. Okay. Anyway. So now we're here. So it's saying it's equal to flags. Now we're telling it go ahead and branch to line 5 or line 4. So right now the input 4 should be coming through. So here's the value 4. And it doesn't happen to make its way here. We're one block off. So I thought we added these repeaters already, but I guess we didn't. And we got to go right here. So the way we do this, we do position 1, position 2, remove that, and then we have 16 lines, but I already built one of them, so then we have to stack this 15 times, and there we go. Okay, so the number 4 is now coming through, and now we're allowing that input to come to the PC. So now we're going to go from line 8 to line 4 because the branch is true. So when I clock it right here, we will end up going to line 4 here, and that should now produce the value 5 out here. Or it's 3? Okay. Oh, maybe? I don't know. Okay, let's see what happens. Maybe this will produce 5. Alright, so the code's a little wrong, but we'll fix that. Okay, what if we did this instead? What if we said A equals B plus C, B is equal to A plus C, C is equal to A plus B. Whoops, alright, screw that. And then let's say we said C is equal to 1. B is equal to 0, A is equal to 0. What if we did that instead? What if we coded that? So what we're going to do is change what gets the value 1 to being C. So this becomes C, which is 3. That's what we're using to represent it. Then what gets the value 0 is going to be B and A. So B and A get the value 0. So the first 3 lines are good. Now what we want to do is we want to change the rights to A, B, and C. So we want to go A, B, and C like that. Then we want to change the left reads to B, A, A. So we're going to go B, A, A. And we're going to turn the right reads into C, C, B. So we're going to go C, C, B. And now that should work. Pretty flawlessly, that should work. So we enable the branch, go to line 0, and then now let's start our code. So line 1, we get a 1. Line 2, get a 0. Then a 0. And then now we should get a 1. There we go. Huh. How is... I am unaware how values are coming in unexpectedly like that. Oh, is it a signal strength issue? Is that what I'm having right now? A signal strength issue? Huh. I thought I fixed this issue already, but I guess it is not fixed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, it's this one here. So it should go 1, 2, 3. Oh, okay, so I'm not even... So I'm reading this line right now. Okay, that seems to be matching. So we're holding a 1 in here. And we're reading That has 3 signal strength. What is it being used? 64, 64, 32. That's what it is. 64, 64, 32, so that should be... Yeah, I think it was just a bug. Huh. Oh, so there's a 0 in here for some... Oh. Oh my goodness. Okay. Yep. That would do it. Okay. Okay. Alright, let's make sure this busing is completed over here. Looks good. Okay. So now that that stupid mistake is out of the way, let's go back to line 0. There we go. Alright, line 1 will give us a 1 on the output there. It's hard to see. Okay. So then we get 0. We get 0. We should get a 1. Good. Nothing else. We should get a 2. Good. We should get a 3. Nice. Alright, so now what I'm going to do is I'm going to purposely change what the flag says and see if it updates to the correct one. So let's refresh our chunks. And so you see how there's a 1 coming through right there? So what I'm going to do is I'm going to update this like that. So now, let me reload my chunks again. Oh, this is being really laggy. Okay. So now it thinks we're greater than. It thinks branch greater than. So let's see if it updates to equal to when I run the next line of code here to see if those 8 ticks of delay was enough. I'm really not liking this lag. Alright. And let's do our branching. So it set the equal to flag. Very nice. Alright. So we know that 8 ticks of delay is enough. So now next time what we can do is we'll put 1 tick here like this. So now instead of 8 we'll go down to 7. And then next time around when it loops we'll do the same thing where we update the flag to the wrong one and see if it updates to the right one on its own. So now we know that when we go to the next line here, it's going to say, yeah, the branch is true. So here it's saying the branch is true. And then now here we're going to be able to jump to the right line, which is line 4. So now we're on line 4, now we should be outputting 5. And something is corrupted here. But this is the game that we have to play here. We have to keep going through and searching for bugs. Okay, so I found a bug. So on the left register here, there's this crap. Get rid of it. Fix it. Make it look like a normal register. Okay, so that was an issue, and then I think we're also stuck in an open read somehow, so what I did is I moved this here, and you see how it's counting up on its own? If we remove this input, shoot. Yeah, so we're stuck in like a read loop where we keep reading and reading. So yeah, the moment I do this, it's just going to start counting up. It's adding 1 to itself every time. It's reading 1. So I got to figure out why this is looping. Okay, Alright, so the bug I found also involves this right decoder, which makes sense if we're continuously looping, and I'm not telling it to. We're 2 redstone block strength short there. You'll notice we have repeaters in every other one here. So all we have to do to fix this stupid freaking mistake is put a repeater there, there, and there. Now that should give it all the strength it needs to get up top. And now let's just make sure the other side has, and yes, this other side all has. And now we will stop boot looping. And so now to show that we're never gonna loop like that, let's put that back. See if it counts up on its own. That's why we were so laggy. Everything I was doing was boot looping on its own, but catching itself before it could loop forever. Except for when after I jumped, and then it would get stuck. And that's why we're getting the wrong outputs. So that's why I recoded Fibonacci. Anyway, so I like the cleaner version of Fibonacci that I coded where it writes A, B, and C in that order. And so now we're on line 0. So if I go line 1, line 2, line 3, line 4, we should have an output of 1 on line 4. Good. Then it should go an output of 2. Good. Then an output of 3. Nice. Alright, so what we're going to do is we're going to change it to the wrong register. We're going to say, alright, make it think it's less than. So it comes over here and it thinks it's greater than, sorry. And so now let's see if it updates to equal to with 7 ticks of delay instead of 8. So if we do this, come over here. And it did not update to the equal to flag. So that means 8 ticks was just the right amount. So we're going to put it back to that. And I'm going to reload my chunks because they're a little laggy. And then I'm going to tell it to update the flags. And now you see we get the equal to flag. Good. So now we will jump, or we will tell it to branch. And now it's telling it to branch line 4, and now we'll say go ahead and actually go there. Now it goes to line 4, and we should be outputting a 5 right now. Yes, so now Fibonacci's working. So now that we output 5, we clock it. It should be an 8. Yes, it's an 8. We clock it. It should become 13. Okay, so now what we're going to do is we're going to spoil the register again. Purposely make it the wrong register to see if it updates to the right one, just to make sure that 8 ticks is correct and it wasn't a fluke the first time. Okay. Now let's see if it says 0 is equal to 0. So, is it? It says, yes it is. 0 is equal to 0. Good. Okay. Now this is the line that says branch line 4, and now when we clock it, it should branch to line 4. Perfect. And now we should output 21. And we have just successfully coded Fibonacci. It may have taken 45 minutes to debug the CPU to the point that we could, but now this will run Fibonacci. I hope you guys are proud.